start with the class. Hello everyone, a very good afternoon. Today we are continuing with the same chapter, that is electrochemistry. Okay, that is electrolysis, and that's an extremely important chapter from your board's point of view and from your competitive exams in the future point of view as well. So today we are to continue with the electrochemical series. In the last chapter, in the last video, I just told you one exception, that why OH is participating and why sulfate is not participating in the reaction at cathode, right? So for that, if you have not watched that, you can just go to my channel and watch the previous video. Okay, so let's start. Let's reveal why was that exception for. So today we are starting with the electrochemical series. Yeah, so just give me a minute, guys. Okay, so let's continue. Electrochemical series. Okay, now the electrochemical series is a series in which certain metals are arranged. Okay, and the whole series we call it as an electrochemical series. The arrangement is so done that the elements that ionizes most readily, okay, is at the top, and gradually the ionization energy decreases as we move down the table. Okay, so let's first write all the elements of this series and then I'll tell you again what it is. Okay, so first of all we have potassium. Yeah, so first of all potassium, then we have calcium. Okay, yes, then we have calcium, sodium, magnesium, aluminum, zinc, ferrous. Okay, then we have lead, that is Pb. Okay, then we have hydrogen, copper, Hg, that is mercury, and Ag, that is silver. Okay, I hope that it's clear to you. Now what happens is, as we move down this table, this is a single table. Okay, as we move down this series, the one which is at the bottom ionizes more easily. Like if we have a competition between these, all are having plus charge on them. Okay, so what will we call them? They will be what? They will be anions or cations? They will be cation. Okay, they will be cation. Okay, because all of them are having a positive charge. Now see, what's the fact here? That when we move down these series, the one which is at the bottom has the maximum ionization power. Okay, now see, silver, mercury, copper, these ionize very easily. Like if on the anode, no, on the cathode, which is the negative terminal, a competition is going on. Okay, see, that which will ionize more readily, Pb or Ag, then we have to just make a competition between them. So who will win? Ag will win. Why? Because it's below lead, isn't it? That's why. So I'll just tell you one more example after we do with the anion table. Okay, so let's now make the anion table. Give me a minute. Okay, so anion table is like we are having every negative ions, sulfate, nitrate, chloride, bromide,
bromine,
okay,
iodine,
bromine, iodine, and then we have hydroxyl. Okay, now see what's happening. The same thing is happening as we move down, the ionization energy increases. Now see, I'll tell you one example of this. So let's zoom in and we'll look at an example. Okay, so for example, I'll give you that we are having this vessel in which we are having water also. So we are having which elements in this? We are having water also, and we are having NaCl also. Okay, so we all know that water will break into H plus and OH minus. Yes, and this NaCl will break into Na plus and Cl minus. Now let's make the two electrodes in this. Okay. So now there are these two electrodes in here. Okay. So I'm making a rough diagram just now. So these are the two electrodes. Okay. Now see what will happen. Now the positive, let's name it as cathode and name it as anode. So anode is what? Anode is positively charged and cathode is negatively charged. Okay. How you can remember it? A for add, so add is positive, and C for cartoon network. Okay, cathode is cartoon network. So cartoon means C, that is cathode, and network, which starts from N, that is negative. Okay, so now see, all the negative ones will go to the positive electrode, like the hydroxyl one, the hydroxide, which minus will go to whom? Will go to anode, right? Just give me a minute. So it will go to the anode. Now see, here chloride is also negative, right? So it will also go, but there's a condition. Only one of the two will get discharged at the anode. Now there's a competition going on now that I'll discharge. They both are saying that I want to discharge. So who will discharge? This fact the electrochemical series will decide. So now let's see the electrochemical series. Now tell me, who is on top? Chlorine is on the top or hydroxide? Tell me. Chlorine is on the top, right? And we know that as we move down the series, the ionization energy increases, right? So who will ionize first? OH will ionize, okay, and chlorine will not ionize in this case. Is it understood now? Yes. So in this, what we need to now rub is this. Okay, the whole thing is getting rubbed. So see, what will happen in this? Only hydroxide will be getting discharged. Okay. Similarly, in the case of the positive ones, H plus will go to the negative, right? Because cathode is negatively charged, right? And Na plus will also go to the negative. Now tell me who will get discharged? H plus is also there, Na plus. Let's see the electrochemical series for deciding that, right? So tell me who is on the top? H plus is on the top or Na is on the top? Na is on the top. So Na will not take part. H plus will win this battle. Understood now? Tell me everybody, please reply first. So now let's move on to the next part. So in the previous videos, I've already told you about the electrolysis of sodium chloride, that is NaCl, electrolysis of acidified water. What was the acid used? To know that, you can watch the previous video. And also we talked about the electrolysis of lead bromide, right? In today's session, we'll be doing the electrolysis of copper sulfate. Copper sulfate is a very, very important compound, and we'll be doing it with the help of two different cathodes and anodes. Okay, so what we'll be doing is that in the first case, we'll be using a platinum electrode, and in the second case, we'll be using a copper electrode. Okay, so let's see the first case. So now we'll do the electrolysis of copper sulfate. So write down the heading, everybody. Electrolysis of copper sulfate, CuSO4. Okay, now by what? By we'll do two electrodes. First, we'll do the platinum electrode, and next we'll do by the copper. Okay, secondly we'll do it by the copper electrode. So let's start with the first one. Okay, let's start with the first one. So let's make the setup first of all. So for that I have to change the page now. So a new page, a new beginning, let's start. So let's make the setup first of all. Okay, so we'll be taking what? We'll be taking a vessel first of all. This vessel will be made up of what? This vessel is called what? Tell me first of all, what is this called? This is called which cell? Okay, so what is the name of this vessel?
Electrolytic cell.
Yeah, it's an electrolytic cell. And inside it, what is filled? Which liquid is filled? It's called the electrolyte, isn't it? Yes. So let's
Yes.
fill the electrolyte inside it, and then we'll just make the electrodes, the two electrodes. So just now we are using which electrode? Just now let's use the platinum electrode. Okay, so we are making a very simple setup just now. So let's name these two electrodes. Let's name one as anode and one as cathode. Okay, so first of all, let's have this as the positive one, that is the anode, and this as the negative one, that is the cathode. Okay, now see what all we have inside it. We have copper sulfate, right? So we will have Cu and SO4, right? And what else will be having? We'll be having water also inside it. Okay, so before continuing, I'll just make you all write all the informations which will be very necessary to be written down in the examinations. So please do take note of these. Okay, so what we have to do, first of all, see what all dissociation will happen. CuSO4, which was there, will dissociate into what? Cu and SO4. Cu will be having what charge? It will be having a 2+ charge. Everybody knows, because sulfate was having -2. Yes, crisscross. And SO4 is having minus charge, right? -2. Okay, the same thing. Now, what else will happen? H2O will also dissociate into what? H plus and OH minus, right? And this H plus, and what will happen? This OH minus will do what? This OH will combine with another one of its type, right? Like this, it will combine with this. Okay, and it will give us what? It will give us water back. Okay, yes, has it given us water back? Yes, it has given us. Okay, and this O which was left will be done what? This O plus another of its type will make what? An O2, because it can't stay like that only, right? So let's now see what's happening at the anodes and the cathodes. Okay, so abhi tak ke liye, for up till now, you have to just know that what all dissociation will happen. Okay, now let's see the different types of things happening at the cathode and the anode. Very important to be written down in the examinations. Okay, so first of all, what do we have to write in the examination? We have to write about the electrolytic cell. What is the electrolytic cell we are using? We are using what? We are using a glass or porcelain. Everybody must be knowing, right? Porcelain jar. Okay, next we'll be using an electrolyte inside that. What is an electrolyte? What we are using as an electrolyte? We are using copper sulfate. Yes, so write down electrolyte. What is the electrolyte? We are using copper sulfate. Yes, and water. Okay, so you can write that copper sulfate in aqueous, right, like that. Okay, and next we'll be writing about the electrodes. So write about the electrodes as well. Elect chip. So the electrode we are using is of what? Electrode what? Of platinum, right? Yes, everybody, is it understood up till now? After that, what we'll be doing? We'll be doing two reactions at the cathode and at anode. Okay, so first of all, write at cathode. So I have told you one fun fact: red cat and ox. Do you all remember this? Yes, very good. So at cathode, what happens? This copper will give away 2 electrons, isn't it? So now see, For understanding this, we just now saw that this copper will be dissociated in 2 plus and this will be 2 minus, right? Right? And we'll be having H and OH also, right? So H plus and OH minus. So what will happen? This Cu will do what? This Cu will go to the cathode because it's positive. It will be attracted towards the negative electrode, and what it will do? It will discharge itself, isn't it? So it will discharge itself. For discharging, what will it do? It's having two excess positive charge, right? So it will give away the two. It will just take two electrons and will become a neutral. Okay, so it will take two electrons and become without any charge. Please close your mic, the one who is open. Yeah, then what will happen? See, it is what? It is copper metal. Okay, now see, Cu and H. As you can see that H must have also, this H must have also gone towards the cathode, right? Yes or no? Because it is also what? Positively charged. But Cu and H ions migrated to the cathode. Cu ions are discharged at the cathode as neutral copper atoms by accepting electrons. It has accepted some electrons and it has become what? Okay, Cu metal. Now see, why H has not been discharged? Tell me what is the reason? I told you in the beginning only. The reason
Electrochemical.
is that yeah, Cu is below H in the electrochemical series. That's why. So here what we'll do, we'll just cancel this H. H is not taking place. Okay. Next we'll talk about this SO4 and OH minus. So this reaction will be happening where? Now see, what is happening here? The examiner might ask you what is happening, oxidation or reduction. So you just have this short form in your head, red cat and anode. So red cat means at cathode what's happening? Reduction is happening. And at anode what is happening? Ox is happening. That is oxidation. Okay, what is happening at the cathode? At the cathode, reduction. Red cat, na reduction. Oh my god, my spelling. Reduction. Okay. Now let's see the scenario at the anode. So let's see what's happening at the anode. At anode, we'll be having two competing with themselves. What are the two?
H plus H minus.
Yeah. So the two are SO4 minus 2, and we have the we also have the OH minus. Now they both will compete with each other. Now tell me who will win in this battle? OH will win. Why? Because OH is, yeah, the reason might be asked in your examination that what is the, you will say that it is lower in the electrochemical series. Very good. So let's just erase this because we all are so generous to know what's happening. So let's write here that only OH will be taking place. So OH will do what? OH is minus. It's having one extra negative charge. It will give away this. It will lose this minus charge to become a neutral OH. Now this neutral OH will combine more with its type. Okay, I have just written it as HO. The thing is same. Okay, it's OH only. So it will do what? It will just react with them to become H2. Just give me a minute. Yeah. So see what will it do? It will combine. OH will combine with this hydrogen. Okay, and will give us what? Will give us water, and this O which is there will combine with another such lonely oxygen and will give us what? Oxygen gas, which is evolved. So what is then at the anode and the cathode? At the cathode we can see that copper metal is there, and at anode what is there? Oxygen gas is being evolved as the product, right? Now see, when the copper ions are depositing, okay, when the deposition of these carbon ions are completed, then electrolysis of water takes place. Now in water, what will happen? Hydrogen gas is liberated at the cathode and oxygen is liberated at the anode. We all know that the blue color of copper ions solution slowly fades. Okay, now see, we all have learned in analytical chemistry. I have told you all a very interesting trick, a very interesting story, I should say, in by which you can just remember the name of every colored ion, isn't it? So I've told you about copper as well. So tell me, my students, tell me, what is the color of copper?
Blue.
Blue. Yes. So now, first of all, it was blue. But what happened due to electrolysis? It was first of all what? It was first of all Cu plus 2, isn't it? It was 2 plus or plus 2, right? So it was blue. Now it is only Cu. So it will be having what color?
Reddish
It will be
brown.
having a brown. In some books it's written red, in some book it is written pink. You can just write it as reddish brown, it's more comfortable. Okay, now see, this reddish brown brown precipitate will go and will deposit on the electrode. That is what, which electrode it goes to? It goes to the negative one, that is the cathode. So at the cathode, what is happening? This brown color deposition happening, oxygen gas is released, isn't it? So what observations can we see? So here write observations in the examination, your electrolytic cell and the electrode which you are using, and then you have to write down the reaction at the anode, reaction at the cathode, and then you have to write the observation. Let's write the observation. So observation, what do we have observed just now? That at cathode, what's happening? Brown Cu metal. It's a metal now. It's not an iron now. Okay, iron is blue. It's a metal. Have you seen a copper wire? It's brown in color, right? So brown Cu metal is depositing, right? And at anode, what's happening?
Oxygen gas is liberated.
Yes, at anode, O2 is liberated. Done. Okay, so that was all for the copper sulfate electrolysis in using a platinum electrode, right? Now we'll be seeing another scenario. The things will be same. Okay, now you will be getting it very nicely. Let's draw the whole structure again. So just now we read about these, right? So I hope that it's clear to everybody. Yes, it's clear now. And those who don't know the color of, so the next case in which copper sulfate will be electrolyzing will be done in the next part of this video. That will be just for 5 to 10 minutes. Please do watch it. It's a very important topic. Till then, a very happy learning to everybody. Stay safe, stay healthy. A very goodbye.